Alright, so this mini lecture is covering simple probability, and we're going to talk about the first two types of probability. So the first type is empirical probability. Here in empirical probability, we have the probability of event A occurring is equal to the number of times A has occurred divided by the number of times the trial is repeated. Next to the right on the next page we have classical probability. So classical probability is determined by the probability of event A occurring is equal to the number of ways A can occur divided by the number of different simple events. Once again, those are empirical and classical probability. In the classical approach, to the right, the underlying process is known. So whatever process there is involved, then that is known to you. With empirical probability, we do not know the underlying process, so we have to do it a different way. So let's look at an example on the next page. So here, our example says NBA basketball player Reggie Miller. He was a great three-point shooter and a good free throw shooter as well. So during his career, he made 5,915 free throws in 6,679 attempts. A is the event, and the event that he makes a free throw. So the question will say, what is the probability of event A? What is the probability that Reggie Miller makes this free throw? So let's solve this on the next page. So we go over to the next page, and then we'll say, let's create a solution. Oops, sorry about that. Solution. The solution is for us to use the empirical formula. So here we're going to say the probability of event A occurring. Right? And once again, if you need to look at the empirical formula, take a look at it. Let's go back. And the empirical formula had the number of times A occurred divided by the number of trials repeated. So that will fit perfectly with our example. So in our example we have, let's move it back over the cursor, 5,915 will go in our numerator. 5,915, and that's being divided by 6,679. So now you just do a little bit of number crunching in your calculator, do this division, and you're going to end up with 0 and 886,000. So that's about 88 or 89% probability that he will make the free throw. Alright, so now let's take a look at another example. The next example talks about M&Ms. So here we have a green M&M, a blue M&M, an orange M&M, and let's say they have a new purple M&M. The question here is, what is the probability that you select a blue M&M if these 4 M&Ms were randomly left in the bag of M&Ms? You shook the bag up. So with that, let's create a solution again. So here we have a solution. Right. So in our solution, we're going to decide whether to use one of the two equations that we had at the beginning. So we could have chose from the empirical formula or the classical formula. Here, in this case where you have the M&Ms in a bag, this case includes equally likely outcomes. So with that being said, we're going to use the classical approach. So the classical approach is the probability of event A, the probability of, we'll call it even more specifically, you're getting a blue M&M, is 1 out of 4. So make sure we're understanding that right and why we chose that. Because we chose the classical approach. The classical approach says the number of ways A can occur divided by the number of different simple events. So therefore, it's 1 out of 4. Right, and if you wanted to, you could actually do the math, crunch that out, and of course you'll get 25%, or 0.25. Alright, so this was a quick rundown on basic, or actually simple probabilities, and we covered classical probability as well as empirical probability.